Welcome to the next session of subject engineering maths. We were discussing chapter 3, that is the differential calculus of calculus module. We were discussing classroom workbook. In the last session, we have finished classroom workbook up to question number 11. Now let us start the session, classroom workbook session, with question number 12. The function f of x equal to 1 by 1 plus mod x, 1 by 1 plus mod x at x equal to 0 is, options are given in terms of continuity and differentiability. Continuous and differentiable, continuous but not differentiable, not continuous but differentiable, neither continuous nor differentiable. Now, when the questions were given like this, if options are in terms of both continuity and differentiability, first give the priority for derivative, because from derivative we automatically get continuity concept, right? So we know that D implies C. So whenever a function is differentiable at a point, implies it is continuous at C. It continuous. Therefore, it is given that we need to discuss this function at x equal to 0. So let us redefine this function, because the function has modulus. Remember always one thing. When the function has modulus, try to redefine the function. Then there is a chance to get both left hand concept as well as right hand, whether it is derivative or in terms of limits. Now at first I will try to find the derivative of this function at x equal to 0. Now before that, redefine this function f of x equal to 1 by 1 plus x if x is greater than or equal to 0. If x is less than 0, then this function becomes 1 by 1 minus x. Because mod x is x when x is non-negative. Mod x is minus x if x is less than 0. Now let us find its derivative. F dash of x is derivative of this minus 1 by 1 plus x square if x is greater than or equal to 0. Now it is again 1 by x minus 1 by 1 minus x whole square. But derivative of 1 minus x is minus. So multiply with minus, it becomes plus. So if x is less than 0. Now here RHD, this is the function for RHD. So minus 1 by replace x by 0, minus 1. LHD, and this is the function for left hand derivative. Replace x by 0, we get 1. Be careful if you don't write minus 1. Here the derivative of 1 minus x is minus 1. If you do not write minus 1, it will be minus 1 by 1 minus x square. Then there is a chance to get LHD or HD both are equal to minus 1. Be cautious about derivatives. So in this case, LHD value equal to 1, RHD value equal to minus 1. Therefore, both are finite numbers and different numbers. Therefore, f of x is not differentiable at x equal to 0. So when a function is not differentiable at 0 or at some point, we can't say about continuity. But if it is differentiable, then it is automatically continuous. But if it is not differentiable, we can't say. It may be continuous, may not be continuous. Okay. So let us try for its continuity. Now what is LHL value? This is the function for left hand side. Replace x by 0, 1. RHL value. So this is the function for right hand side. It is 1. So LHL value, RHL value, both are finite numbers and equal. Therefore, limit extends to 1. This is limit extends to 0. F of x equal to 1. But this one, I can treat it as f of 0. Because when x is equal to 0 also, the function is same. Replace x by 0, you get 1 by 1 plus 0, it is 1. So this one is nothing but f of 0. So limit value is a finite number that is equal to functional value. Therefore, f of x is continuous at 0. F of x is continuous at x equal to 0. Therefore, it is continuous at 0 but not differentiable at 0. Continuous at 0 but not differentiable. So option B is right option, not this. Now let us move to question number 13. This question is related to limit values when x tends to infinity. So the question is limit extends to infinity, square root of x square plus x minus 1 minus x is, see, one option is infinity, another is minus infinity, one is 1 by 2, one option is 0. When you replace x by infinity, people think that this is infinity, infinity minus infinity is 0. It's wrong. Infinity minus infinity is undefined. So therefore, there is no chance to get infinite values in this case. Now let us try to get this answer. So here this is limit extends to infinity. Here square root terms are there. So x values are approaching to infinity. In that case, so try to rationalize this. So this is a, for example, this is b. It is in the form a minus b. So rationalizing factor is a plus b. Multiply this and divide with the rationalizing factor of this expression. So this becomes square root of x square plus x minus 1 into x into square root of x square plus x minus 1 plus x divided by the same expression. So square root of x square plus x minus 1 plus x. So this is the rationalizing factor of this. We have multiplied this with its rationalizing factor and divided with the same. So therefore this is limit extends to infinity. A minus b into a plus b. So this is a value, this is b, and this is a b. A square minus b square. So square root will be eliminated. So x square plus 1 minus x square divided by square root of x square plus x minus 1 plus x. This and this term will be cancelled. So this is the limit extends to infinity. X minus 1 divided by square root of x square plus x minus 1 plus x. Now here you can take x value common. Here when you take x square common, when it comes outside square root, it becomes x. But here x term is there. Therefore, this limit value must be equal to limit extends to infinity. I am taking x common from numerator. It becomes 1 minus 1 by x. Here take x square common. It comes as x. So here I can take x square into 1 plus 1 by x minus 1 by x square along with the square root plus x. Now this is x, square root of x square is x. So x you can take common. So therefore this limit will be equivalent to limit extends to infinity x into 1 minus 1 by x. You can take x common, x into square root of 1 plus 1 by x minus 1 by x square plus 1. So what we have done is we have rationalized this and we have taken x common from numerator as well as from denominator. This and this will be cancelled. So replace x by infinity. 1 by infinity is 0. 1 by this will be 0 and this will be 0. So this will be 0. Now this is 1, 1. This is 2. So the answer is 1 by 2. So option C is a right answer. Note this. This is limit n tends to infinity square root of n square plus n minus of square root of n square plus 1 is, it's a blank question. Let us work out this. Now this is similar to previous question. Rationalize this. This is equivalent to limit n tends to infinity. So square root of n square plus n minus square root of n square plus 1. Multiply this with its rationalizing factor. Square root of n square plus n plus square root of n square plus 1 divided by, multiply with same. So therefore this is square root of n square plus n plus square root of n square plus 1. So therefore this limit is equivalent to limit n tends to infinity. It is in the form a minus b into a plus b, a square minus b square. So n square plus n minus of n square plus 1 divided by square root of n square plus n plus square root of n square plus 1. Plus n square minus n square get cancelled. So this will be equal to limit n tends to infinity. n minus 1 divided by, here I can take n square common, here I can take n square common, they come out as n. So I will write like this, this is n square into 1 plus 1 by n with the square root, plus here n square common, 1 plus 1 by n square with the square root. So therefore you can take n common here, here also n. So therefore this limit is equal to limit n tends to infinity, n minus 1 divided by, you can take n common, this is n into square root of 1 plus 1 by n plus this one is square root of 1 plus 1 by n square. Now here you can take n common and cancel out with the denominator n. So limit n tends to infinity, n into 1 minus 1 by n divided by n into square root of 1 plus 1 by n plus square root of 1 plus 1 by n square. Now this n gets cancelled, replace n by infinity, 1 by infinity is 0. 1 by this quantity will be 0 and this is will be 0. So this is again 1 by 2. So the answer is 0.5. This is just like previous question, rationalization followed by cancelling n from numerator and denominator. So you get 1 by 2. Question number 15. A function f of x is defined as f of x equal to e power x if x is less than 1. This is ln x plus ax square plus bx if x is greater than or equal to 1. So here function is defined in two different forms. Below one function, above one another function. Then which one of the following is true? Option A, f of x is not differentiable at x equal to 1 for any values of a, b. So here a is one unknown, b is one unknown. It is given that it is not differentiable at x equal to 1 for any values of a, b. Option B, differentiable at x equal to 1 for unique values of a, b. That means a will be single value, b takes single value. In such case, it is differentiable. C, it is differentiable for all values of a and b at x equal to 1 such that a plus b equal to e. Option D, it is differentiable for all values of a and b. Right. See, when you look at all options, it is related to differentiation at x equal to 1. Now the function takes two different forms. Below one, this is one function, above one, another function. So we need to go for left hand and right hand derivatives. Let us find the derivative. Here f dash of x equal to derivative of e power x if x is less than 1. Now its derivative is 1 by x plus 2ax plus b if x is greater than or equal to 1. Now what is LHD? LHD equal to e power 1 e. What is RHD? RHD equal to replace x by 1, we get 1 plus 2a plus b. 1 plus 2a plus b. Now it is given that in the first option it is not differentiable at x equal to 1 for any values of a and b. Now you can see here, suppose if I take this combination, if for example a equal to minus 1 by 2, for example b equal to e, implies LHD must be equal to RHD. So take a value minus 1 by 2, that means this will be 0, b value e, then LHD value equal to e, RHD value will be equal to e. So in this combination, if a is minus 1 by 2 and b equal to e, LHD must be equal to RHD. In that case, it is differentiable. But in option A, it is given as it is not differentiable for any values of a and b, but this contradicts this particular statement. Therefore, option A is wrong option, because in this case for this combination LHD and RHD are same. Now look at option B. It is differentiable at x equal to 1 for unique values of a and b. Now this is one combination, but we do not know whether only these four values LHD and RHD are equal, maybe some other values. Let us see. Suppose I can take a value e by 2. Suppose I can take a value e by 2. If a equal to e by 2, For example, b equal to minus 1, then also LHD must be equal to RHD. Look at this, because we cannot do modifications in this because this is fixed constant E. But here RHD depends on values of A and B. If A value E by 2, 2A becomes E. B is minus 1. Minus 1 plus 1 gets cancelled. This becomes E. So LHD, RHD equal to E. In this combination, both are LHD and RHD are becoming same. In the second combination, LHD and RHD are becoming same. So in the second option, it is given that it is differentiable at x equal to 1 for unique values of A and B. But here for multiple values of A and B, we were getting like this. So it seems to be option B also wrong. Now when you look at C, it is differentiable at x equal to 1 for all values of AB such that A plus B equal to E. Now this is one possible case where f of x is differentiable. But in this case, when you calculate A plus B, we were not getting E. Therefore, option C is also a wrong option. Option D, f of x is differentiable at x equal to 1 for all values of A and B. Now suppose I will take A value 0. Suppose if A value 0, comma B value 0, then RHD becomes A value 0, B value 0, RHD becomes 1, but LHD equal to E. In this case, LHD is not equal to RHD because the value of E is not equal to 1, it is 2.71. So, but in this combination it is not working, so it seems to be option D is wrong. But even I can't say that option B is also right answer because A seems to be wrong because of this, C seems to be wrong, D seems to be wrong, but even B is getting to be failed. But how it is possible all options are wrong? So there is some twist in this question. That twist is, here it is a differentiable at x equal to 1. Since it is differentiable, we know that all differentiable functions are continuous. Let us use that concept. So differentiable implies continuous. Therefore, LHL must be equal to RHL. Now what is LHL? This is the function. Replace x by 1. For RHL, this is the function. Replace x by 1 log 1 0. So it is A plus B. So this is one equation. Now one equation is, it is given that the function is differentiable. So LHD and RHD must be equal. Since f of x is differentiable, LHD must be equal to RHD. Now what is my LHD? E. What is RHD? 1 plus 2A plus B. 1 plus 2A plus B. We call it as equation 1. So we have two unknowns in A and B. A and B are two unknowns. So solve equation 1 and 2. We get A value single value. A takes single value. That is exactly one value. Even B takes a single value. So therefore, f of x is differentiable at x equal to 1 for unique values of A and B. So just we have to apply, if a function is differentiable, it is continuous. So based on these two equations, when you solve A and B, you will get single values for A and single value for B. So option B is right statement. So very tricky question. Try to understand this. Okay, note this. Now let us move to question number 16. Consider the function f of x equal to mod x whole cube, where x is a real number. X is a real number. Then the function f of x at x equal to 0 is option A, continuous but not differentiable. Once differentiable but not twice. Twice differentiable but not thrice. Thrice differentiable. See, we have two concepts. One is a derivative, another is continuity. Continuity we always discuss one time. But regarding derivative, we have many orders. First order derivative, second order, third order, fourth order. Continuously you can have derivatives. So this is a very tricky question. Continuity can be discussed only one time, but you can discuss derivative any number of times. So at x equal to 0, we need to discuss its derivative of all orders, at least up to 3, because in options, derivatives are there up to third order. Continuity only one time. Now here the function contains a modulus operator. Let us redefine this function. This is x cube if x is non-negative, greater than or equal to 0. So when x is greater than or equal to 0, mod x is x. So it becomes x cube. Suppose if x is less than 0, mod x becomes minus x. Minus x whole cube is minus x cube. Now let us find derivative at first. So here f dash of x equal to derivative of x cube is 3x square. If x is greater than or equal to 0, this is minus 3x square if x is less than 0. So when x is less than 0, this is derivative. When x is greater than or equal to 0, this is derivative. So what is RHD? 3 into 0 square, 0. LHD minus 3 into 0 square. So it is 0. Both are finite numbers and same. Therefore, it is differentiable at x equal to 0. So once it is differentiable, ultimately it is continuous. Okay. But in the option A, it is given as continuous but not differentiable. But it is differentiable because of this. So therefore, option A is wrong thing. Now let us go for second order derivatives. Here f dash of x equal to derivative of this 6x if x is greater than or equal to 0 minus 6x if x is less than 0. Now in this case, this is f double dash x. RHD equal to 6 into 0, LHD equal to minus 6 into 0, 0. Both are finite numbers and equal, so it is differentiable 2 times also. Now when you go for third derivative, third derivative of f is 6x derivative 6 if x is greater than or equal to 0 minus 6 if x is less than 0. Now in this case, RHD equal to 6, LHD equal to minus 6. Both are finite numbers but different numbers. Therefore, it is differentiable twice but not thrice. Therefore, f of x is differentiable twice but not thrice. But not thrice at x equal to 0. So, what is correct option? Twice differentiable but not thrice. So, option C is right answer, not this point. Now, let us move to question number 17. What it is? The function f of x equal to modulus of x plus 1 on the interval closed interval minus 2 comma 0. What is the function? F of x equal to modulus of x plus 1. What is my interval? Closed interval minus 2 comma 0. It is continuous and differentiable. Continuous on the interval but not differentiable. Neither continuous nor differentiable. Differentiable but not continuous. See, this is very familiar example for us. Now it is in the form modulus of x plus 1. Now this can be written as modulus of x minus of minus 1. So it is in the form modulus of x minus k, where k value is minus 1. Now this function is not differentiable at minus 1. Except minus 1, it is differentiable at all points. So therefore f of x is differentiable at all points except at minus 1, except at minus 1. And unfortunately this minus 1 belong to this interval. Minus 1 belong to closed interval minus 2 comma 0. So therefore the function fails to be differentiable at least one point in this interval. Therefore it is not differentiable. But we know that the graph of this function is always continuous irrespective of any interval. Therefore it is continuous f of x is continuous but not differentiable. It is continuous but not differentiable, because when you look at the graph of this function, it is always continuous. But its drawback is -1 in terms of derivative. Unfortunately, -1 belongs to this interval. So if a function has no derivative at least one point in the interval, ultimately it is not differentiable. So continuous but not differentiable. So option B is right. Now let us move to question number 18. This is limit x tends to 0, x into e power x minus 1 plus 2 into cos x minus 1 divided by x into 1 minus cos x is blank. Limit x tends to 0, x into e power x minus 1 plus 2 into cos x minus 1 by x into 1 minus cos x. It's a blank question. Now try to replace x by 0. This will be 0. Cos 0, 1. 1 minus 1, 0. Denominator 0. So it will be in the form 0 by 0 form. When you have 0 by 0 form, apply L'Hospital rule. So this is limit x tends to 0. Here to find the derivative, apply product rule. X into derivative of this e power x plus e power x minus 1 into derivative of x is 1 plus 2 into derivative of this minus sin x divided by, here again apply product rule because this is a dot symbol, apply product rule. X into derivative of 1 minus cos x sin x plus 1 minus cos x into derivative of x is 1. Now this is limit x tends to 0. When you replace x by 0, this will be 0. 1 minus 1, 0. Sin 0, 0. This is 0. This is 0. Again we were getting 0 by 0 form. So that means apply L'Hospital rule for the same problem second time. So again apply product rule here. X into e power x plus e power x plus derivative of this e power x plus 2 into derivative of sin x cos x. So therefore this is minus 2 cos x divided by, here apply product rule once again. So x into derivative of sin x cos x plus sin x into derivative of x1 plus 1 minus cos x derivative sin x. Now replace x by 0. This is 0. This is 2. 2 minus 2, 0. This is 0. This is 0. Again we were getting 0 by 0 form. So let us apply L'Hospital rule third time again. So this will be limit x tends to 0. Now this is x into e power x plus e power x only for this. Now this is 2 e power x, derivative is 2 e power x. Cos x derivative minus, already minus is there. So plus 2 sin x divided by, apply product rule, x into cos x derivative 1 sin minus sin x plus cos x into derivative of x is 1 plus this is 2 sin x, derivative is 2 cos x. Now replace x by 0. This will be 0. This will be 0. This will be 0. This will be 0. But this is 3 divided by, this will be 0. This is 3. So the result is 1. That means in this problem we have applied L'Hospital rule 3 times, right? And followed by product rule many number of times. So finally we were getting 1. Note this. Now let us discuss question number 19. A function f of x equal to 1 minus x square plus x cube is defined in closed interval -1 comma +1. The value of x in open interval -1 comma 1 for which the mean value theorem is satisfied is. So function is given. Its domain is closed interval a comma b, that is -1 comma 1. We need to find value of x in the corresponding open interval for which the mean value theorem is satisfied. Mean value theorem is satisfied. Here name of the mean value theorem is not specified, but single function is given. Ultimately It can be either Lagrange's or Rolle's theorem. So let us verify Lagrange's theorem at first. Now this is A value and this is B value. This is a polynomial expression. If it is a second degree polynomial expression, the value of x is the midpoint of this. See, they were asking x value. That means indirectly they were asking c value in open interval a comma b. If it is a second degree polynomial, then c is nothing but midpoint of this interval. So it's mean of this interval. Mean of open interval -1 comma +1 is 0, and anyhow 0 is not in options. Therefore 0 cannot be right answer, because it's not a second degree equation. If it is a second degree polynomial, definitely the value of x in open interval -1 comma 1 is the mean of the value, that is 0. But 0 is not there. So let us verify this. Here condition 1, f of x is continuous in closed interval -1 comma 1. This is very clear. And condition 2, this is a polynomial expression, so it is differentiable in open interval -1 comma +1. This is very clear. Therefore, by Lagrange's mean value theorem, there exists c belong to open interval -1 comma +1 such that f dash of c equal to f of 1 minus f of -1 divided by 1 minus of -1. Because a value is -1, b value 1. We have applied Lagrange's mean value theorem. This implies, what is f dash of c? Minus 2c plus 3c square. What is f of 1? 1. F of -1 is -1 divided by 1 minus of -1. This implies 3c square minus 2c minus 1 equal to 0. Now, it is a quadratic equation in the unknown c. When you solve this, you will get two roots. But you need to select a value which belong to this particular interval. Let us solve this. The equation is 3c square minus 2c minus 1 equal to 0. This implies 3c square. This we can write it as minus 3c. We can write it as minus 3c plus c minus 1 is 0. So this implies 3c into c minus 1 plus 1 into c minus 1 equal to 0. So this implies 3c plus 1 into c minus 1 equal to 0. So this implies either c equal to -1 by 3 or 1. But this 1 does not belong to open interval -1 comma 1. 1 is not a member. Therefore, the value of c is -1 by 3. So option B is right answer. Note this. Now let us move to question number 20. The Lagrange's mean value theorem is satisfied for f of x equal to x cube plus 5 in open interval 1 comma 4 at a value rounded off to the second decimal place of x is blank. So this is just like previous question, but they were asking x value, c value rounded off to the second decimal place, accurate to second decimal place. It's a third degree polynomial. If it is second degree polynomial, it will be midpoint of this. What is midpoint? 1 plus 4 divided by 2. 5 by 2, this will be 2.5. If it is a second degree polynomial. But this is third degree, so mostly answer will be close to 2.5. Answer will be close to 2.5. So this is true for second degree equations, but for general polynomials, c is close to midpoint value. Now here this is a continuous function in closed interval 1 comma 4, because this is a polynomial expression. Since it is polynomial, it is differentiable in all intervals. So in particular, it is differentiable in this interval. Therefore, by Lagrange's mean value theorem, f dash of c is f of 4 minus f of 1 by 4 minus 1. So f dash of c is 3c square. F of 4, 69 minus 1 by 3. So this implies 3c square equal to this is f of 1 is this is 6. 63 by 3, this is 9. Sorry, this value is 21. So therefore C square equal to 21. C 3C square is 21, C square is 7. So C is square root of plus or minus 7. But it must belongs to open interval. So therefore C value equal to root 7. So this will be approximately 2 point, I think 63 or 65. So here C value is approximately 2.65. Note this.